A second important technology, which is in this case more widely applied in several ports, is port automation. So what is automation in maritime logistics and transportation? Industrial automation is the set of technological solutions that allow mechanical, hydraulic, pneumatic, electrical, electronic, or computerized system or elements to be used to control machine and processes, thus reducing human intervention and heightening control over equipment and processes. So at the terminal level, at port level, it is possible to automate access control system at terminal gates. So the automation is taking place at gate. So the connectivity with the hinterland. Storage and distribution operation in freight yards. And third, in quay cranes, used to load and unload containers. So pretty much we have sort of three levels automation: at gate, at yard, and at quay, at the wharf, so with gantry cranes. Here I've provided you a figure where you can see a map, a world map, with the major automated ports worldwide. We can see that there is, when it comes to fully automated terminal, so pretty much terminals in ports where there is almost no human intervention, the Far East region is leading. So China with the port of Shanghai and Jintao, the port of Busan as well, Japan, the port of Rotterdam in Europe, and the port of LA in the US are leading containers port when it comes to automation. Here I've taken a video from APM terminals. So we it's related on APM Maersk terminal operation, and it's particularly related to port operation in Maasvlakte 2, which is the port of Rotterdam. So it's quite interesting to see how the port has automated operation and how port operation works at automation levels. So I hope you enjoyed the view of this video. hope the video was interesting. And one more port which is taking automation at another level is once again the Port of Singapore. And the Port of Singapore has been planning a new development of a new port area called Tuas New Port, and this is will be a newly constructed 65 fully automated unmanned automation terminals. I think the capacity will be about 60 to 70 million TEU, so huge capacity. It's been partially completed in 2020, but of course it's a very limited space. The full completion will be in 2040. The next technology is about big data. So, a definition of big data. What is big data? Big data is the branch of technology focused on designing and running the set of computer architecture and technology used to store and process data and information in quantities that exceed conventional system processing capabilities. So big data is information recorded by sensor and devices. We know this is done via IoT. So IoT is mainly the collection of data, and then we need big data capabilities for processing such data. And the data is processed in real time and on a massive scale using big data technology, so big data softwares. One interesting aspect of big data is digital twins. So digital twins are digital replicas or representation of a physical asset, typically composed of a set of variables that, when combined and processed, can describe and predict the behavior of the industrial assets to be monitored. So the big data can store different streams of information and can help optimize several port processes. Overall, big data can help optimize port supply chain processes, can also help reducing delays in the port and congestion in the system, and increase the efficiency of the different players and facilities. Another technology is virtual storage. And virtual storage, as the industrial and commercial segments have grown, most systems for managing, storing, and processing digital information have migrated to a virtual storage model. As we were saying, for example, digital twins are a representation of real products within a digital environment, within a cloud. Virtual storage can provide access to multiple services in a distributed and scalable way. This model includes technology solutions like digital containers, cloud computing, and edge computing. And the application of virtual storage are extremely wide and important. For example, imagine if you store one specific product in a digital environment, and then you're able to manufacture that specific product whenever it's needed for repair, for example, or for maintenance. That is very much connected with 3D printing. So virtual storage and 3D printing are quite interrelated technologies. So within virtual storage, cloud computing is extremely important. So cloud computing is used to describe the provision of computing services like infrastructure, server and storage, platform, databases and programs, and application and other resources over the internet. So of course, ports need to use cloud computing to store information retrieved via IoT. But also we have edge computing, and edge computing is based on computing and storing part of the data close to the end user. For example, for ports, So cloud computing is more general, it's the whole process, while edge computing is storing data which are close actually to the final consumer, to the end user. For example, for ports, edge computing can provide a distributed model that makes it easier to access and process that information generated in vessels in real time. And of course, this reduces congestion in central nodes, thus lowering latency in operation, bandwidth needs, and energy consumption. So as you can see, the final output for edge computing, for IoT, for big data, they're all quite strictly interrelated. I would like to show you another video, and that's a more general one, but I think it's also quite an interesting one. And this is how Antwerp port. Antwerp is again a leading port. Is the second biggest container port in Europe. That's located in Belgium, and how the port is a model for smart shipping technology. So I think the video is quite interesting, and it's taken from Tech Insider. It's available like the other videos in YouTube. So I do hope you enjoyed the view of this video as well.
So the Port of Antwerp, a lot of containers are coming in, millions of containers every year. The chance is quite big that the coffee you drink in the morning has one day passed through the port here. Port business is not anymore about moving stuff. With the emerging technologies which are coming up, let's also how can I optimize my supply chain? How can I do that in a more sustainable way by using technology as an enabler? So the Port of Antwerp is the second largest port in Europe. It's about 120 square kilometers. The result is that the port today is 6 times the size of the city. So size matters because the ships are becoming bigger and deeper. The terminals became bigger and more efficient. Already today on the seagoing ships, there is already a lot of technology present, but what didn't happen is that the overall supply chain was optimized.
The most important processes in shipping are external processes which require a lot of collaboration. So when a big ship arrives here and all the trucks come here to pick up their import containers, literally more than 100 of containers have to be transferred to the truck drivers per hour. And you have, thanks to the capabilities of blockchain, a perfect track record. So you can see who has transferred at what particular moment. This creates a kind of micro ecosystem around one container.
It's important that the goods are tracked, that they are delivered on time. Certainly in these times of e-commerce, where fast delivery is crucial, we feel the pressure from customers that we have a very predictable delivery. So to keep an eye on that, we build our digital twin, where we connected different sensors. We connected the 500 cameras in the port, we connected our pipeline information. We brought together 12 different databases with financial information, GIS information, depth information. So bring in more sensors, bring in artificial intelligence, bring in machine vision.
So in a digital twin for the port, it's most important to have all the information of the waterways available. Then of course the companies that are using our ports and the ships that are transporting the cargo across the ports. If we select a ship, we can see the last 3 hours of where that ship has been. This gives a really nice view of the depth situation, and it shows the ships in relation to the depth. By combining all these different data sources in one view, we have a super situational awareness of the whole port. I think we're ahead of many ports, and I think we're ahead of many cities as well.
One of the main drivers of success for the city of Antwerp is a collaboration between work we're doing in the city and the port. Because we know if we have a dumb city, we're never gonna have a smart port. Just like the port has a digital twin for all their port operations and logistical capabilities they're running in the port, we've created a digital twin for everything happening in the city. And we're using between 1,000 and 5,000 sensors. And this type of digital twin can actually help us make better decisions within the confines of, for example, mobility, air quality, noise pollution, and so on.
I think we are, since about 10 years, in a period of exponential growth of new technologies. By using drones, For instance, we can do fast interventions by using machine vision. We can automate the inspection of our maritime infrastructure. I think smart is, of course, it doesn't mean that all the things which were done in the past were kind of dumb, but I think smart means that more technology is coming.
Shipping is a very old technology. Shipping was, and I stress the word, was certainly very conservative. A new generation of people who come now, people who have been raised with IT technologies, and they understand this is an opportunity for them.
I always say the port business is kind of untapped potential. I think we are just on the start of that, of bringing new technology into the business. And there's a huge potential.
Another interesting technology is provided by blockchain technology. So what is blockchain? Blockchain is a kind of distributed ledger technology, or DLT. It is used to perform digital transaction in real time and in a secure and distributed manner. You might have heard of blockchain because of cryptocurrencies. For ports, one of its most notable applications is to container tracing and tracking services. So via blockchain technology, it could be, there would be the enablement of greater visibility of the flow of containers, import and export operation, taking place all along the logistics chain. So there is one specific sort of case study, and that's quite interesting, is steel taken as from the port of Antwerp in Belgium. And as you can see, this is an article that I've taken, and this titled Blockchain Smart Port Case Container Release. And that's the use of blockchain technology for securing and more efficient container handling operations. So an example of a blockchain smart port, again, is given by the Port of Antwerp, where in the summer of 2017, the Port of Antwerp announced a pilot project. So remember at the beginning we were talking about testing new technologies. So this is not a full implementation, but rather is a pilot project, and see what are the benefits that can be obtained from the implementation of a blockchain. So it's a pilot project for more efficient and secure container handling, leveraging blockchain technology. And 2017, an update of the project was released, putting in the new technology more into perspective. It is to be said that this is a project that involves the port, of course, as a smart port, but it also involved the city of Antwerp as a smart city. So the Port of Antwerp key is in the city economy, has seen its freight volume grow for several years, and is Europe's second largest seaport. So the Port of Antwerp is quite proud to market itself as an innovation hub and as a port that is implementing smart technologies. So, but why should we consider implementing blockchain in ports? Again, this is taken from the example of the Port of Antwerp. So we know that for every port and every transport system, it's important to move a container from A to B. However, to move a container from point A to point B, it involves more than 30 parties and an average of 200 interactions between them. Even more, there is a lot of paperwork. There is a lot of documents that need to travel with the same containers. Overall, given the number of stakeholders and given the number of documents involved, there is usually a slowdown and inefficiency of operation. So pretty much there is bureaucracy involved. The blockchain technology implementation can really improve such areas. So the blockchain pilot of T-mining, that's how the project is called in the Port of Antwerp, revolves around a particular use case, securing and picking up containers. So there is a very specific area, segment of container handling. So what's the difference with a traditional port? In a traditional port, truck driver usually pick up containers and need to identify themselves. For example, at the gate, the truck driver need to present a certain number of documents in relation to the identity of the driver, to the truck itself, and to the container content, origin, and destination. In the Port of Antwerp, this is different. They use AlphaPass identification system. So there is a PIN code generated for the particular container by the port terminal operator. And the code is passed to the carrier for container picking. So pretty much it all works with a code rather than with documents. So there is a problem, of course, of security with this PIN code. The code might be mishandled and given to a wrong person in some cases. So this is where it comes blockchain. With blockchain, only the parties involved have access to relevant information about a container. So there is no external parties which are able to obtain such information. Digital rights are created in the blockchain to identify the owner or agent of the container. Only the owner of the corresponding rights is allowed to collect the container on the terminal. And the right can be transferred via blockchain, making the system very fast and very safe. I will stop here the second part of this presentation, and I will get back in the third session with artificial intelligence. Thank you very much. Welcome to the third part of this presentation. Sorry, Tashi. Sorry. Okay. Yeah. Welcome to the third session of this KOICA presentation, and that's about artificial intelligence. No, sorry, Tashi. Sorry. Moving on with the third session, we continue with exploring technologies of smart ports and the fourth industrial revolution more in general, and that's about artificial intelligence. So, what is artificial intelligence and how is it different from machine learning? Artificial intelligence, known as AI, is a branch of computer science focused on developing and combining a logarithm created in computers. It aims to order, to learn and make connections and observation normally done by human reasoning. So basically it's an intelligent machine. How is it different from machine learning? Machine learning is a subset of artificial intelligence, and overall it can automatically detect patterns in data and make predictions and decisions about future situations. So artificial intelligence and machine learning as such are those important technologies, applications to gain insight from our data. So a few applications of machine learnings in ports. These are just few examples, but there is much more than this. But currently, port managers are using artificial intelligence to predict traffic conditions and wait and delivery times for trucks at the entrance to the terminals. So we know that gate congestion is one impeding issue for several ports worldwide. The second one, for example, is to calculate or estimate how long containers remain in the terminal, predict the date and time of ship's arrival, or shed light on vessel loading and unloading patterns. So application of machine learning are very important to make forecasts, to make estimation, to make predictions about cargo flow or asset flows. So to go a bit deeper, let's see what are some practical application for ports with machine learning. So real-time berth planning. Berth planning is a complex exercise usually done by port managers. So berthing slots and labor can be better used by forecasting ships' arrival times more accurately, and that might result, this is just an estimation, in an up 8% points of EBITDA, so a financial indicator for terminals. So by forecasting in a better way ships' arrival, we are certainly able to sort of better assign slots and stevedore gangs, for example. The second one is predictive maintenance for key assets. So predictive and remote cranes and vehicle maintenance can lead to a 30 to 50% reduction of total machine downtime, increasing the availability of critical port assets such as ship-to-ship cranes and RTG cranes, so in the yard. So predictive maintenance is something we've seen with IoT and with artificial intelligence and machine learning, the reduction in cost by predictive maintenance, so we avoid breaking down of machines and more heavy repairs, for example, by knowing how to perform maintenance in a predictive way. The third one is automated yard planning. Again, yard planning is a very, very complex process within ports. And advanced analytics and modeling make it possible to swap assets, reroute containers, and adjust routing and speed in real time. So in real time, we're able to optimize processes as a matter of fact. And the fourth one is demand planning at gate. So more accurate predictions of consumer and production behavior can help terminals better estimate demand for gate arrival. So in this case, we're able to sort of by forecasting, by predicting certain processes, we're able to have a smoother operations at gate. So I would like to show you another video. This is taken from Port Technology, and that's how artificial intelligence will affect port and terminals. I hope you enjoy as well.
Artificial intelligence, AI, is of course at the moment a true hype word. If even Elon Musk uses it regularly, it must be something. Now, AI has been around for a very long time, so this is not something new. However, the availability of data and the availability of linked computing and the Internet of Things make the power of such learning behavior, such pattern recognition software much greater. So the reach becomes much greater. So, as we already discussed, the container industry is very repetitive in its nature. That also means that learning from the past helps you improve decision making in the future. So within the terminal operating systems or within surrounding intelligent modules, there's great potential for using AI technology to enhance decision making. One hurdle to take is quality of data. So we all know the phrase garbage in is garbage out. So until we get solid information throughout the supply chain, shared and put in to those algorithms, it will become very difficult to make good, high quality decisions. And yet today, the quality is still quite poor. So the discipline to ensure when a ship leaves, to give a simple example, that your outgoing BAPLI is exactly according to the stowage on the ship, that's unfortunately still a rare event. So we're dealing with input, which is, well, at best so-so, and we're trying to feed powerful algorithms with that, and we have to, address that. One of the other areas where I would expect to see more AI to be implemented inside automated equipment. So what we have seen so far is automated equipment that is purely centrally controlled. So there's very little autonomy on the vehicle. Now, the question is, where will it lead to? But I would expect there will be more intelligence inside the vehicle, so it can operate without central guidance for a longer period during operations. So it becomes also less sensitive to disturbances because it can actually continue without this continuous feed of instructions. You can think of moves within the stack that are automatically generated by the stacking crane because it sees opportunity, it has some idle time. It thinks, okay, I don't get instructions from my central system, but I know containers are wrongly placed. Let me solve it. So we'll see developments in that area. On the other hand, I'm a strong believer that within contained systems, relatively small like container terminals, if you look at the amount of moving parts inside a terminal, it's very limited. So the power of central computing can easily deal with that scale. And central intelligence gives you an overview, gives you this holistic view, which always leads to better decisions. So I think there will be coexistence of partial autonomy and intelligence inside modules, inside equipment. On the other hand, a central optimization from a TOS, from an equipment control system.
The next technology is about virtual and augmented reality. So virtual reality and augmented reality are technologies that combine images in real time and in an interactive way. So we know that virtual and augmented reality have a widespread application in several areas, one of them being the gaming industry. Very much the gaming virtual reality provide a very much interactive way in playing games and video games. So what's the difference between virtual reality and augmented reality? For virtual reality, it's a fully immerse the user in virtual information, and the augmented reality, it complements the real information that the user perceives. So of course there is a lot of applications that are currently used in particularly in warehousing systems to find products and to retrieve quickly products. But application imports are also very interesting, and I think the most interesting application for virtual and augmented reality comes from education and training in particular. So for ports, it might complement the information that workers perceive in real time, so providing extra information to port workers, to stevedores, and so on. It might help to visualize port facilities. So of course, this is an interesting application when it comes in education and training. Specifically, if we think, for example, of simulation centers, of ship simulation, of port simulation, even crane simulation, that can be very, very helpful. But also it can warn of potential emergencies or dangerous situations. So by emerging the port worker in a specific scenario within a port, fire, for example, a container catching fire in the yard equipment, or there is a ship accident, how would you react? What is the contingency plan? Well, by virtual and augmented reality, that can really help the port environment becoming safer and really more prepared to specific situations.